Week 8, Wednesday, Transformation Study Guide. Read question number 1, please.
Use the figure to the right. B is the image of point A. Point A is called the pre-image.
Right. Go.
B. Write the translation vector that moves point A to point B.
Okay, so A is a pre-image. So then from here, A is going back this way, correct? And then going this way, correct?
Yes.
So it should be a negative A and then down A. Good. All right, number 3, or C.
Write the translation from point A to point B using coordinate rotation.
What did you write?
Or I didn't do that one.
X minus 8, Y minus 8. That's it. That wasn't too difficult, was it?
No, I just forgot the name. Okay.
So I'm going to do Control F1. Control F1. There we go. All right, D.
Suppose point B was obtained by reflecting point A over a line. Draw the mirror line M on the graph.
Well, okay, so then this will probably be the mirror, correct?
Yeah.
Did you draw that line right there? Do you see that?
Yeah.
And then you want to use exactly the same words that they're using. So it says draw a mirror line M. So then you want to label this as mirror line M, correct?
Yes.
Where A reflected over M to get B. Does that make sense?
Yeah.
Yeah. Okay, E. Did you write down the description? Mirror line M, where A reflected over M to get B. Would you like this one? Here you go. That's really good. Okay.
I can't.
You can have it. I don't think Emma wants it, so it is yours. Okay, next one, read. Did you hear me? Go. Would you read, please? Did you write it down? Keyword. What does it say?
Segment AB.
This is a segment, correct?
Yes.
Definition of a segment means that you have 2 endpoints, like that, correct?
Yes.
Okay. Line M. Line M is this green line right there. What can you say about line M?
It's perpendicular to
Yeah.
segment AB.
You could say, well, also not just perpendicular, but it's also a segment bisector, which means it splits AB in half, correct?
Yeah.
So use the correct word.
Okay.
Segment bisector to segment AB.
Okay.
Okay. 2.
On the quadrilateral ABCD is translated using the transformation x, y is x plus 3 and y minus 4. Give the coordinates of the image.
Tell me how you do it.
So what I did is I basically just added the 3, or like so in point A, I would just add the coordinate notation to point A, which means -2 plus 3, which is 1, and 2 plus -4, which is -2.
So first one to plot this, correct?
Yes.
3, 4, 5, 1, 2. C, D is 1, 2, 3, 4, 5. So this kind of looks like a trapezoid, correct?
Yeah.
All right. Transform that. So x is, you're going to go over to the right 3, correct? Down 4, correct?
Yeah.
1, 2, 3, 1, 2, 3, 4. That's your A prime, correct?
Yeah.
B, 1, 2, 3, 4, 1, 2, 3. Oh, I'm sorry. 1, 2, 3, 1, 2, 3, 4. That's B prime, correct? C, 1, 2, 3, 1, 2, 3, 4. C prime. 1, 2, 3, 1, 2, 3, 4. D prime, correct?
Yeah.
So then you just draw this, right? So we drew it, we labeled it, give the coordinate of the image. So then what you need to do is do A prime, B prime, C prime, D prime, correct?
Yeah.
Now you could count it or you can just add it. So for this one, you're just gonna add a 3 and a minus a 4 to each of the coordinates. Do you see that?
Yeah.
3 minus 2 is a 1. -4 plus 2 is a -2, correct?
Yeah.
The same thing, plus 3 minus 4. B prime is 8, -2. Do you agree?
Yeah.
What's C?
1 or -5.
Okay, what's D?
8 and -5.
There you go. That's it, right?
Yeah.
Okay, next one. Let's move on. Okay, what's next?
Use coordinate geometry to prove or disprove that equilateral ABCD in number 2 is a parallelogram.
How do you prove that something is a parallelogram? What would you need to have?
I would need to have
Like, what do you notice about the sides? What do you notice about the angles?
sides.
For equal sides, that's a square. Maybe you should draw a picture of a parallelogram. Draw a picture first. Draw a picture. What are the sides? All 4 sides equal or just certain sides equal? What?
Certain.
Which one? What do we call it?
On the sides.
Which sides? You need to be a little bit more specific. Read this part. What does it say there?
Both pairs of opposite sides are parallel.
Opposite sides, correct?
Yeah.
A parallelograms look like this, correct?
Yes.
Like all 4 are not the same, because if they're exactly the same, it will be called a rhombus, correct?
Yeah.
This side has to be the same. These 2 sides have to be the same, right?
Yeah.
Okay. So if I have to prove that, and it says quadrilateral ABCD, so it's not the blue one. They're asking you to prove this one is a quadrilateral, correct? So the set of points I'm going to be using are these original points, right? So first thing I'm going to do is if we have to prove that opposite sides are parallel, which means they have the same slope, correct?
Yeah.
So same slope. This is A, B, C, D. A is -2, 2. B is 5, 2. C is 1, -1. D is 5, -1. Okay, they need to have opposite sides are parallel. So opposite sides have to have the same slope. Which sides are we going to look for the slope? Slope of AC has to be the same slope as which other? BD. Slope of AB has to be the same thing as? Let's find that. I'll find AC, you find BD, okay? Let me know when you find the slope. Okay, so you're finding BD, correct?
Yes.
So when you're finding BD, you get a label x1, y1, x2, y2, correct?
Yes.
So -1 minus 2 is what you show on top, correct?
Yeah.
That gives you a -3, right?
Yeah.
I don't know how you got -1, but it's a -3. 5 minus 5 is on the bottom, so it should be -3 over 0. Anything with a 0 in the denominator is undefined, correct?
Yeah.
So your slope is what for BD? Undefined, correct?
Yeah.
My slope that I found for AC, I want you to find the slope of AC. Number it and find it, please.
-1.
Good. It's -1. So what do you notice about the two? Are they the same?
No.
No. So go back to the question. Prove or disprove? Are you going to prove or disprove in this case?
Disprove.
Disprove because why?
Because both parts of the
Not both. We just proved one. We just proved the pink side.
your opposite sides aren't the same.
Are not the same
No.
slope.
So
Yeah, they're not the same slope. So write that in a sentence. I am disproving quadrilateral ABCD is a parallelogram because you just go back to the question and rephrase it, okay? And then explain your reasoning why. Okay, so that was only the pink side, correct? If I really want to prove the other opposite side is AB should be parallel, or the slope of AB should equal to the slope of CD, correct? To prove that the green sides are parallel, which means they have the same slope, correct? So I'm gonna have you find, do you wanna find CD or AB? You choose.
CD.
Fine, I'll find AB.
Also, that was rude.
Yeah, it is rude as AF.
Rude at like how mine's on his laptop when.
No, like pee. I'm like, did he just pee in his jammies?
He probably did. He doesn't like taking showers. He's like Noah.
He recorded. Stop it. Okay. Let me know when you're ready. So because the slope of AB is 0 and the slope of CD is 0, you know that the green two sides, they are indeed parallel. But unfortunately, both pair of opposite side have to be parallel. You can't just have one, right? Now, another one that you can do the test. I mean, this already is not a parallelogram because I already missed that side, correct? Read over here. Both pairs of opposite sides are what?
Are equal in length.
So, if I'm going to do the pink side, so you will have to find the distance, right,
Yeah.
of AC has to equal to the distance of BD, correct?
Yeah.
What's the distance formula?
It was like square root square root minus or what
It could be x2 minus x1. It doesn't matter which one's first.
x1 squared plus y2 minus y1.
You want to find the distance of AC or BD? Your choice. Take one.
Only 8.
Which one?
80.
Fine. You find AD. I'll find AD. You mean BD? It's either BD or AC. AD is a diagonal. That's not an option. Fine. I'll find AC.
I just do.
Okay. You did BD, correct? Explain to me how you did it.
What is AC?
Okay. It's not 2, but explain to me how you did it.
Okay, so I use the extra. So I use -2 and 1 in the x value for the formula. So then I place it.
Okay. So what minus what, first off?
1 plus 2.
Okay. 1 plus 2, which is 3, correct?
Yeah, 3
Okay. Squared. Okay. What's y?
9.
What's y?
-1, so -3 and 3 squared is 9.
Yeah. So what's 9 plus 9?
18.
Square root of 18. That's not 3, or that's not 2. So what's the square root of 18?
2 square root 9.
No. 2 square root 9? No. No. Look over here. I freaking forget how to do this. What times what gives me 18?
9 and 2.
What's the square root of 9?
3.
So it's 3 square root.
2.
Do you get that?
Yeah.
Okay. BD is 3. Now looking at the 2 is AC. The distance is the same as BD.
Yes.
3 square root 2 is the same thing as 3.
No. No. No, it's not.
So then what can you say about this?
Um, AB or AC and BD are not congruent to each other.
Good. Okay. So we're down to 3. Let's move on to the next one. Number 4. What does it ask you to do?
ABC has vertices.
4. Number 4. We're not done with the other one yet.
Okay.
Number 4.
Use coordinate geometry to prove or disprove the diagonals of quadrilateral ABCD and number 2 are congruent.
Okay, diagonals, correct?
Yes.
So you have A, which is -2, 2, B, which is 5, 2, C, which is 1, -1, and D, which is 5, -1. I want you to take a color pencil and draw your diagonals. What are the diagonals?
The diagonals are one negative or -2 and 2.
Now, the diagonals, when you draw it, is AB, correct? Or I'm sorry, CB, and then AD, correct?
Yeah.
So label them and then put the points next to it. Going back to the question, what do you want to do with the diagonals?
Prove or disprove that if they are quadrilateral.
That's not what you're doing. No, that's not what you're doing. Go back to the question and read it again. Make sure you understand what they're asking you to do.
Use coordinate geometry to prove or disprove the diagonals of quadrilateral.
None of the diagonals are quadrilateral. That doesn't make any sense. So keep reading. The diagonals are what?
A, B, C, D,
Are what?
and number 2 are congruent.
So what do I need to prove that the diagonals are what now?
Mhm.
Congruent, which means what? That they're equal in distance, correct?
Yeah.
So what are you going to need?
Distance formula
What's the distance formula again?
equals square root x2 minus x1 squared plus y2 minus y1 squared.
Can you do that? So we need to find a plan. What's your plan? What are the two diagonals?
The two diagonals are CB and AD.
So let's find the distance of those two and see if they're equal. Can we do that?
Okay.
Are the diagonal the same?
No.
So then write that down. So the diagonal of CB is not equal to AD because CD is 5 and AD is square root of 58, right? So go back to the question. It says use coordinate geometry to prove or disprove. So you say, I disprove the diagonals of quadrilateral ABCD in number 2 are not congruent. Does that make sense? We're going to stop right here. We'll finish the rest tomorrow. Okay?
Yeah.
All right, that's it.